All right, cool. So as we go through these notes, you can write on your notes however you choose to. The biggest thing we're going to be doing today is just kind of brainstorming and discussing how these changes take place. I think it will be easier once you see it all in place. If not, obviously, we'll discuss it. Okay. So first thing we have here is it says circle the quadratic parent function from the graphs below. Well, you got A, B, and C here. We talked about the linear parent function back when we were talking about slope. And the linear parent function was y equals mx. It was this perfect equation that meant that it had no y-intercept, went right through the origin, so it was proportional. And it also had a slope of up 1 over 1, up 1 over 1, up 1 over 1. Well, for the quadratic parent function, it's going to be very similar to that. It's going to be y equals x squared. Notice there's no y-intercept. Notice that it's just very simple. What I want you to do is open up your calculator, and in your calculator, I want you to type in y equals x squared in the y equals section. Y equals x squared. And when you type in y equals x squared, you should see this nice, neat parabola that goes right down to the origin. It has one x-intercept, and it comes back up. It's almost like a perfect wishbone on your graph. Do we agree?
Yeah.
And so by looking at that, we can tell that the correct answer is going to be B for our parent quadratic function. Can anybody tell me why A is not the correct answer? Why is A incorrect? Colin? It doesn't go through the origin. Can we all agree with that? It cannot be the original, most simple, basic parent function if it does not go through the origin. Can anybody tell me what the difference between B and C is?
It's a negative parabola.
It's a negative parabola, which means what, Hayden?
That it goes down.
It goes down. Can anybody tell me what that equation would be?
Maximum.
Y equals
Negative
negative
x
x squared.
Yeah, good. Y equals negative x squared. Y equals negative x squared. So just like with the linear equations, everything that we're doing is going to be based off of this equation right here. I want to know how has it changed from that parent function. So every time that we're looking at these, whether it's going up, down, left, right, flipping, reflecting, it's going to be what is the change from this parent function. Does that make sense? Okay, awesome. Okay, so now it says match the following graphs with the correct equations. On yours, it's spaced out, so you should see them next to it. So like you have 2 pages. Yours is going to be in that top right corner, and we're going to be matching those equations with these ones right here. Do you understand?
Yeah.
So what I want you to do real quick, since I don't really have the luxury of being able to have them both on the same page, that's my fault. I want you to go ahead and try to match these letters, and then we'll talk about them. The way that I would work on matching them is I would literally go into your y equals, and I would type them in, and then hit graph, and see which one matches which one. That's what I would do personally.
Wait, so 2, 3, and 4 will match up with 5, 6, and 7?
No, sir. 2, 3, 4, 5, 6, and 7 are all the equations, and if you look on the right side of your page for a minute, you're going to see A, B, C, D, E, F, and we're going to match those up. Does that make sense?
Yeah.
So what I'm going to do is I'm going to just take a piece of paper up here so that for the graph we can kind of look at it together. And I'll write up here. So while y'all are working on it, I'm going to work them out as well, and then we will compare them. Hey, what's up, son?
I borrowed calculator.
Absolutely, man. Why don't you why don't you give me back that calculator and grab a different one?
Alright.
Are we finding success by typing these equations in and being able to match them?
Yes.
Okay, good. That's gonna be the fail-proof method. That's gonna be the one that makes it easier on you. In just a second, when you guys are finished, I'm gonna kinda go through some of the simplicity things, some of the simpler ideas, things that helped me out. But I want you to be deferring to the y equals. We're gonna be a couple more seconds. Okay, cool, take your time, no rush, no rush. Alright, here we go. For number one, or I guess number two technically, I got D. 3 I got E. 4 B. 5 C. 6 A. 7 F.
Yep.
Alright, hey, now I'm going to just kind of run through this really quickly. The y equals is definitely the best method. But if I look at my graphs, for D, I knew that the answer had to be for this one because it was the only one that had a y equals at -7. Or a y-intercept at -7. For number 3, when I looked at, okay, I don't have a y-intercept, which means that it has to go through the origin. Can we agree? Well, I only have 2 that go through the origin. I guess I have 3 technically. One that goes up and one that goes down. We just talked about the opposite of the parent quadratic function, which is how I knew that number 4 was going to be through the origin going down. 5, I got C because it was the only one that had a positive A value and a y-intercept of 5. 6 for A, it was going down. And 7, it was the only one that had a negative A value and a y-intercept of 5. So do we see how there are also ways that you kind of balance those ones out?
Yes.
Alright, sweet. So now if we go to the next part of this, I'm going to go and scroll down. And I'm going to scroll past these graphs. I'm going to get to part 8. Which of the following is the equation for the linear parent function? Which following is for the linear parent function? What's the answer? A? Oh, okay, my bad. I couldn't tell if you're saying A or F, and I was like,
He said,
I get it now. I get it. My bad. So we're all understanding with the linear, right? It's just the slope one. Linear means straight line. What about quadratic? Which one's going to be quadratic of those A, B, and C over there?
B.
B. You have to know the parent function. If you don't know the parent function, you're going to have a lot of trouble. Okay, are we good there? Okay, number 10. 10 through the rest of this page, basically. We're going to talk about how we would describe these changes. So this says, describe how the graph y equals x squared minus 3 would be transformed if it were changed to y equals x squared plus 3. So here's what I want you to do. Go to your y equals. In your y equals, in y1, I want you to type this first equation. So for y1, you're going to type y equals x squared minus 3. And for y2, you're going to type in y equals x squared plus 3. Don't do anything after that. Just type them both in for me. So in y1, we're going to have y equals x squared minus 3. For y2, we're going to have y equals x squared plus 3. Okay, you got those both typed in? Then you're going to hit graph. And I want you to watch your screen as you hit graph. Now, for those of you that are using the computer, you're lucky that your graphs are 2 different colors. For those of you that are using the Game Boy, you're only going to have the pixelated black lines, do you understand? So like Stone, you're at an extreme disadvantage in this. Okay? If you look at your graph though, when you look at your y equals, so hit y equals again, it shows you that your y1 is going to be the blue line. Do you understand? And then it shows you that your y2, I think, is like a red line. Okay, so then if you hit graph again, tell me, how did those lines change? How did the blue line change to become the red line? What happened? Don't overthink it, just tell me. What happened? Tommy.
It went up 6.
It went up 6. Could you circle an answer choice that says it went up 6?
Yeah.
That's all it is. It went up 6. And it might not even say it went up 6. It might even just say something as simple as it moved up. Did your parabola change? Not really, it just went up. Obviously by going up, it kind of forces it to get a little bit tighter. It's not as wide, but that makes sense because it's not growing as quickly. Are we good with that? All right, try number 11. You're going to go to your y equals. We're walking through this again. You're going to type in y equals x squared plus 5. And then in your y2, you're going to type in y equals x squared plus 13.
Wait, can you say that again?
Number 11, dude. Y equals x squared plus 5. And then you're going to put for y2, y equals x squared plus 13.
It's kind of off the graph.
Ah, okay. Hayden said it's kind of off the graph. What do you mean by that, Hayden?
It's not on the coordinate plane we have.
Well, what does our graph go up to? It only goes up to 10, right? And so if we're talking about a y-intercept of 13, doesn't it make sense that it's going to go up? Okay, let's talk about this though. Did I change my x squared at all? So did I change the value of my actual problem? All I did was I literally shifted the parabola up. Are we okay with that?
Yeah.
Okay?
Yes, Joy?
Alright, let's go to number 12. Hey AJ, can you look at the iPad and tell me how long the video is so far?
12 minutes, 20 seconds.
Perfect, thank you. Okay, number 12, just based off looking at it, can we agree that we're going to go from positive 10 to negative 6? The line is going to do what? Shift down. Are we all okay with that?
Yes.
I just want to move on to some of the other ones to show you. So let's do it 13. So for 13, I want you to type in y equals x squared. And then I want you to type in y equals 4x squared. And hit graph.
That's a steep climb.
Alright, how would you describe that to me?
It's a steeper parabola.
It's steeper. The parabola got skinnier, right? Can we say that? The parabola shrunk in a little bit. So here's how this is going to happen. If you want to add this to your notes, I would write this down somewhere. The bigger the a value, the skinnier the parabola. The bigger the a value, the skinnier the parabola. The bigger the a value, the skinnier the parabola. The bigger the a value, the skinnier the parabola. But let's think about why that makes sense. Well, your a value is showing you how rapidly it's increasing. Well, if my numbers are increasing by larger increments, that means that they're not spacing out more. They're growing at a quicker rate, which is going to make it increase and get bigger faster.
Mr. Baker, what time do you want the thing to stop?
And I don't want it to exceed 15.
Okay, 10:14.
Okay, cool. Will you just hit the red button for me?